Hello. Kita Welcome to this session 1C on machine learning. Let me introduce you the chair of this track, Dr. Anuradha Jayakadi. Dr. Anuradha Jayakadi is an assistant professor at the Department of Information Systems Engineering, Faculty of Computing at the Sri Lanka Institute of Information Technology, and he is heading the Department of Postgraduate and Research. He received his PhD in Electrical and Computer Engineering from Curtin University of the Technology, Australia, and his MPhil of the Statistics and Computer Science is from the University of Peradeniya, Sri Lanka, and his MSc is from the Sri Lanka Institute of Technology in Sri Lanka, and PhD in Computing from the University of Greenwich, UK. Having exposed to the various sectors of ICT, he is an eminent researcher whose career objectives include widening the skills through the continuous learning and the implementation of emerging technologies in ICT. As a researcher, he has published over 100 plus research papers, 11 journal articles, and 3 book chapters. His research interests include assistive technology, indoor navigation, machine learning, IoT, digital transformation, and hydroponics. He has over 27 plus years of experience in his field of ICT. Currently, he is heading the Industry Engagement Unit attached to the Faculty of Computing at Sri Lanka Institute of Information Technology. He has been working at Fibre since the year of 2007 and as a university associate attached to the Curtin University, Western Australia since year 2014. He has been a BCS member since 2001 and chartered ICT professional since 2007, and also a chartered engineer, senior member of IEEE, MIET, MACM, MCSSL, and Internet Society. Currently, he is serving as an assistant secretary of IET Sri Lanka. He is a founder and managing director of Oronton Labs Private Limited. So we'll move to the presentation. Over to you, sir.
Yeah, thank you, Pimini, for your kind introduction. I think according to the conference, 21st International Conference here, normally according to the game rule, we are giving 10 minutes for the presentation. And as soon as you finish the presentation, we will open forum for the Q&A session. And then we are moving to next one. Likewise, we plan to move on in this session. If I try to say something about this track, actually, it's about machine learning. It's a type of artificial intelligence that allows software application to become more accurate and predicting outcomes without being explicitly programmed to do so. Because machine learning is the study of computer algorithms that can improve automatically through experience and by the use of data. It seems as a part of artificial intelligence as well. Then nowadays it is very hot topic and burning word as well, machine learning, and is used in interest normally internet search engines, email filtering, to identify spams. Likewise, more areas we are working with the machine learning. Normally, in computer environment, you can see good people as well as bad people. Now, if good people working with the machine learning, they are giving good outcomes, and bad people can do more sabotage to your systems even. Likewise, keep those kind of things on your mind. I would like to move our presenter. Presenter actually paper titled Prediction of Students Stratification Online Learning During the COVID-19 Pandemic. It's a case study on Sri Lankan universities, authored by Senanthan, then Manjunan, then Dr. Kumara and Hiruni from Sabaragama University of Sri Lanka. All the presenters who is the presenting today, then we will like to hand over session to you all to do the presentation about your paper. Over to you. Can you all hear this one?
Good afternoon all. I am here to do our research presentation titled on Prediction of Student Satisfaction on Online Learning during the COVID-19 pandemic, a case study on Sri Lankan universities. I am Sendan Prashant and my co-supervisors are Mr. Vanujan Kuganeshwaran, Professor BDGS Kumara and Dr. Hiruni Rupasinghe. These are the topics which I plan to discuss during this presentation: introduction, followed with significance of the research, objectives, and as well as the sub-objectives, then the methodology, followed with results and analysis, conclusion, finally, the recommendation and the references. First of all, let me commence with the introduction. Everyone in the world, even in every part in the world, know about a term called coronavirus, the COVID-19. It created too much of restrictions in our day-to-day life, routine works, and all of our all the components that related to our life. Especially, it created an important gap in the education as well. Especially in the higher education institutes around the globe have been engaging untiring efforts to provide continuous learning opportunities for the students and to safeguard their welfare. With the help of that point, it's difficult to grab what we mean by that. If a particular student has been entered into the university or a classroom, he or she can grab more point rather than effectively participate in the online classes and stuff. So that gap has been arised due to this pandemic situation. But there are several institutions and there are several multinational companies focusing on reduce the gap between student and the teachers that can be arise during this pandemic situation because of this COVID. So during this research, by considering only the student side perspectives and the factors, it's important to investigate the true experience of university students in not only in Sri Lanka, all over the world, but we have specifically focused on Sri Lanka using the e-learning facilities throughout this period of this epidemic situation. Still the pandemic situation has been continuous. I think all of you have already heard about there is a new variant has been arrived in the African countries and it has derived through the Hong Kong as well. It's a kind of an important and the derived variant. It's a kind of a derived variant. So still the pandemic situation has been going through. We have to face and defeat that one and focus the adoption of e-learning in the universities. After this epidemic situation, we need to ensure students have been satisfied with the existing platform or not nowadays. For that, this prediction model by ensuring several fields and by feeding certain factors, we can ensure the student can satisfy with the existing learning and adoption of e-learning in the future. He or she will okay with that or not with the help of the prediction model. It's important to predict that one, whether the existing students satisfy with the system and have the willingness to adapt the system in the future as well. So in order to develop this research, the main objective has been considered as the development of a prediction model to identify the satisfaction of the students who are willing to adapt the e-learning during this pandemic. Still, some of the students are not interested in adapting these e-learning materials, and it's for an intelligent student. I have seen it directly. even though he is an intelligent student, he didn't have a full concentration on this online platforms after this pandemic situation and both the scenarios. So we have to predict, we have to identify whether the student is okay with the e-learning platform during this pandemic situation, even according to these new variants and stuff. Still the pandemic is going to go on until the particular problem resolved. It's not going to get resolved until they have found a solid vaccine. Still, we have the vaccination 1, vaccination 2. Now the booster also going on, but the pandemic is still continues. So until that one, we have to ensure the student is okay to adapt the e-learning in the future as well, because it's difficult to come to the normal position at a limited time period. So until everyone goes settled, we have to wait. For that case, we have to ensure the students is okay to adapt the e-learning in the future as well. In order to support the main objectives, several sub-objectives have been identified. The most important factors in predicting the student satisfaction. There are more features, but we have focused on only the certain factors to develop the prediction model, because some features have been not considered as not important to develop the prediction model. And we have only focused on 2 machine learning algorithms rather than focusing on multiple algorithms. Even there are multiple classification algorithms. We have only focused on support vector machine and artificial neural network. We are currently doing a research to increase the accuracy of the prediction model by considering the student perspective factors. We are currently working on it to expand the research more further to determine the best technique. The several certain basic evaluation matrices have been identified, and based on that one, we have used a particular technique from support vector machine and artificial neural network. Out of 2, we have select one technique and develop our final prediction model with the highest accurate one. So, as I mentioned earlier, to develop the entire prediction model earlier, the questionnaire was developed based on 3 types of question, 3 categories of question. I will explain that one in the next slide. So with the help of that questionnaire, the questionnaire has been forwarded in between 12 universities in Sri Lanka, the private and as well as the state universities. And we have received around 909 responses by considering the multidisciplinary factors. No, not only multidisciplinary factors, multidisciplinary disciplines. For an example, computer science, MA degree, arts degree. We have considered several degrees, and as well as we have focused on all of the universities by considering the private and as well as the state universities. And we have received around 909 responses. And out of the 909 responses, 189 were not interested in involving the e-learning in the future, as well as you can able to see it from here. Out of 909, 460 students were identified as satisfied with the adoption of e-learning in the future. At the same time, 260 are neutral with both the sides. They can satisfy with the physical attendance in the future and as well as satisfy with the e-learning as well. So with the help of this one, you can easily identify out of 909 responses, beyond the half of the students have been interested in adapting the e-learning in the future as well. So as I mentioned earlier, the questionnaire consists of 3 categories of question. Initial part is to obtain the personal information of the respondent. So earlier I mentioned we are only focused on the student factors, but there are some other factors also involved in the student satisfaction. We need to focus on the lecturer perspective, and there are several restrictions that can be facilitated by the PHI and as well as the UGC. We have to focus on that one as well. The expand version of the research we are currently doing on the expansion version of the research. But in this research, up to this point, we have only focused on the student factors. The second part is to obtain the details of the technological items used for the online learning and the language proficiency. This is a kind of an important factors that influence the each and every student and restrict the each and every student to learn. Even a particular student is familiar with the physical attendance, and once he focus on a particular lecture, he can grasp more. But for the same student cannot grasp more even if it's online. We have noticed that one as well. So the final part is to obtain the info related to the usage of e-learning. For an example, I can directly elaborate the third point. I am too much familiar with Zooms by conducting lectures and stuff, but I am not familiar with the Microsoft platforms. I'm not familiar with Microsoft platform. So it's a kind of a burden. So I have to go to the YouTube and I need to learn something. Then only I can be familiar. And most of the times and the conferences and lectures will be conducted through Zoom. We are already familiar with Zoom. But if you need to switch to a different platform, there's a resistance. So we need to avoid that one as well. So we need to, similarly, they are already familiar with up to from grade 1 to 13 and after the universities for 2 years. They are already familiar with physical attendance and interacting with the lecturer directly. But if we, due to this pandemic situation, we have told them to switch to submit the assignments online. And rather than writing it, you have to print it and submit it online. You have to focus on it. So we need to ensure the student has been satisfied with the system or not. Even though they are not satisfied, they have to work on it. But we can increase their satisfaction by absorbing their instinct. So for that case, the prediction model has been developed. So this is the high-level architecture of the methodology. Data set with all the attributes have been considered, the numerical and as well as the categorical attributes. For an example, the university is kind of a categorical attribute. There are several universities that need to be considered as the categorical attribute, but there are several numerical attributes as well. Age, the demographic factors related to the particular student. And from that entire data set with all the attributes, only the particular attributes have been selected with the intention of fed it into the machine learning models. And as most of the machine learning algorithms can be interpreted or produce results if the data has been fed as a numerical variable. So that's why we have converted the certain categorical variable into the numerical variable with the help of the label encoding as well as the one-not encoding method. And the data set with numerical values, once the data set has been converted into a numerical value, then the data set has been divided into training and testing, and the hyperparameter has been done with ANN and as well as the SVM. And by considering the certain basic evaluation matrices, the technique has been selected earlier. And after that, in order to ensure the certain technique outperform against the other technique, in order to ensure in another way, cross-validation also performed with a particular data set. And based on the results obtained from the basic evaluation matrices and after the cross-validation with a mean accuracy, final prediction model has been developed. So as I mentioned earlier, the training and the testing, once the data set has been converted into a numerical value, for the training, 70% of the data set as well as 30% data set has been used for the testing purposes. And for the ANN, SVM has been developed with the help of the Python programming as considered as the core programming language, and the scikit-learn library has been developed, used as the library to develop the SVM, and Keras has been used as the library to develop the ANN. And K-fold cross-validation with 5 folds have been used for the cross-validation technique. And finally, for the hyperparameter tuning, grid search CV method has been used. And as well as to develop the final prediction model, ANN has been used with the help of the results. I will explain it more. So according to, as I mentioned earlier, all the features have been considered as not important for the development of the final prediction model. So these highlighted red highlighted attributes have been removed from the data set by considering that has been not important for the development of the final prediction model. Initially, the timestamp, district, resources used for the online learning, mode of connecting to the internet, method used in the online learning, types of material used in the lecture, and as well as recommend best e-learning methods. But even though there are several other categorical variables as well, but those need to be converted into the numerical value. One is university, that one also important, the degree also important, and then the gender. That one that has been converted into the numerical value with the help of the one-not encoding method and then as well as the label encoding method. So from the results obtained by considering the basic evaluation matrices by considering the SVM and as well as the ANN technique. For the SVM, we have received around 70.03 percentage of accuracy, and for the ANN, we have received around 76.19. By considering the basic evaluation matrices, ANN outperform against the SVM So these are the hyperparameters that has been identified with the help of the grid search CV method. We have identified the hyperparameters for SVM and as well as the ANN, and these values have been set. Once these values have been set, we have received the accuracy of 76.13 for the ANN. And from this, by considering the basic evaluation matrices, we have decided the ANN is a good technique to develop our final prediction model. And in order to ensure the ANN is outperform against the SVM, again, the data set has been cross-validated with the help of the K4 cross-validation, and we have received around the mean accuracy of 75.01 for the ANN, and we have came up to a final conclusion that final prediction model has been developed by using the ANN. We have developed the ANN to develop our final prediction model. So then the recommendation. So in here, according to our research, we have only focused on the student perspective factors, but we didn't focus on the factors that related to the lecturers and travel restriction that related to the PHI, and there are several restrictions and the factors need to consider that related to the UGC. We didn't focus on it. We are currently working on that one as well, and also by considering the ensemble techniques and bagging and boosting techniques, we are trying to increase the accuracy, because even though this model has been developed with the ANN, we have received the accuracy around 76.19. We are now trying to tune this model, and by considering some other boosting and the bagging techniques to increase its accuracy, along with the attributes that related to the lecturer and the UGC circulars and stuff, by focusing on several stakeholders. The suggested prediction model development in e-learning would probably assist and provide more efficient learning opportunities to the students as well as the teachers and the lecturers to decide on the adaptation of e-learning after this pandemic situation is required or not. We can easily focus on if the model will be developed like this with the increased accuracy. We are trying to increase this one rather than make it in the 70%. We are trying to increase by tuning the existing models, and as well as by considering some other ensemble techniques to make it as an hybrid and stuff. So these are the references which I have used to develop these slides and as well as to develop our manuscripts. And so this is so it's a kind of an quote. Online learning is rapidly becoming one of the most cost-effective ways to educate the world's rapidly expanding workforce. But even though online learning is a cost-effective way to educate the world, we have to ensure the students have been satisfied with the online platform or not. It's a mandatory requirement for everyone. So that's all. Thank you for the attention, and it's a great privilege to thank you for giving this opportunity. So if you have any questions, you can ask. That's all. Thank you. Thank you so much.
Thank you very much for presenting your research outcome. Now, forum is open for the questions. Okay, till others asking question, I'll ask one question from you all. Now, based on which criteria you are giving the accuracy here?
Which criteria means I didn't get this.
Yeah, is there any benchmark for you to give you this 76% accuracy? How you are saying that kind of accuracy is there? Your results, your outcomes.
Based on the responses received that we received, most of them are actually saying that they are okay with the adoption of e-learning in the future. Based on that one, that's the benchmark that we have.
Yeah, you say like that, man, because now you say some of them like online, some of them like physical. Is there any people who like both online and physical? That means hybrid mode.
Yes, sir. There are some students, sir. Yeah.
How many is there? Do you have any memory?
Yes, sir. Around 180 number of students. Around, yeah.
Is there any factor you have considered as poor internet quality, lack of device, and those?
Yes, sir. Those are the poor internet quality were discovered in most of the areas, sir. And they have most of the time they have mentioned based on the Likert scale we have created that prepared the data set. According to that Likert scale, we have discovered that most of them are not familiar with the e-learning platform. That is the important factor that we have discovered from the particular responses.
Then how you validate your outcome, your framework?
We didn't test with the real platforms still.
Yeah, okay, thanks. Any question from the audience? Okay, I think, then thank for presenting your research outcome in this conference. Okay, then by thanking all the authors of prediction of student satisfaction on online learning during the COVID-19 pandemic, a case study of Sri Lankan universities. I'll thank all of you and the presenter as well. Then I would like to move to the second presentation.
Thank you, sir.
Yeah, thank you. It says titled TrackNet, Deep Learning Approach on 3D Curves for Segmenting White Matter, authored by Kumaralingam from Eastern University, then Kokul from University of Vaunia, and Sitampalam from Eastern University, and Nagalingam from University of Jaffna. Okay, the session is for you.
Hello everyone, I welcome you all to my presentation. We named our approach as TrackNet, a deep learning approach on 3D curves for segmenting white matter fiber bundles. Before move into the slides, I would like to introduce myself. I am Logiraj Kumaralingam from Eastern University of Sri Lanka, and I am very happy to be a part of this wonderful event, ICTR 2021. This is the overview of my presentation, and you will encounter all these topics as I move forward. Rather than wasting time, let's move to the slides. We all know the brain is the most important and complex organ in the human body. The brain consists of two tissues, namely gray and the white matter. The gray matter is formed by the aggregation of neuronal cell bodies, dendrites and terminal, and which function is to producing signals and processing information. When we come to the white matter, it made up of axonal nerve fibers and it bind up various regions of gray matter. In the figure, you can see white matter and the gray matter of the brain. In our work, we only focused on the white matter of the human brain. The collections of axons together form a fiber bundle. There are three major types of fiber bundles identified in the human brain. They are association fibers, projection fibers, and commercial fibers. These white matters are used to investigate the effect of normal changes, diseases, and injuries in the brain. In the figure, you can see some of the major white matter bundles identified in the human brain. The organization of white matter pathways and structures studied using diffusion MR imaging and fiber tractography. Diffusion MR imaging is used to study the structure of the human brain, and it measures the diffusion of water in the tissues. And it is the only unique tool for non-invasive investigation of fiber nerve tracts. When we come to the tractography, it is a 3D modeling technique used to visually reconstruct the fiber tracts from the whole brain. There are many algorithms developed in order to reconstruct the fiber tracts from the brain. As the result of the fiber tractography, it's more useful in the quantitative analysis of the structural characteristics of the brain. In the figure, you can see how each individual tract is computed by propagating a line in both directions from the seed point until a predefined stopping criteria are met. There are many methods use different techniques in order to segment the white matter bundles from the whole brain tractography. They are manual methods, automatic methods, and some traditional machine learning algorithms and deep learning techniques. When we come to the deep learning, the CNN give high performance in segmentation because of its hierarchical structure. CNN-based fiber segmentation approach are classified into two groups. They are voxel-based segmentation and fiber-based segmentation. CNN model used to learn the characteristics of the fiber bundle by consuming large amount of input data and complex structure. In the figure, you can see the fiber bundle as a volume and a fiber bundle as curves. So our motivation begins with the reliable and robust segmentation of 3D fiber curves into anatomical meaningful fiber bundle. It's not an easy task due to its complexity and large volume. Also, the track-based analysis of fiber bundles are important task in the clinical field. Therefore, our objective of this research is to develop a deep learning architecture in order to segment the 10 major fiber bundles and to segment the curves which do not belong to these 10 major fiber bundles using the curve raw data format. And these are some related work that already done for segmenting the major white matter bundles from the whole brain. They use different methods, for example, the CNN and there's some traditional machine learning algorithms with the use of different input data format. We found some limitation in their methods too. And this table shows the comparison between these related work as supervised approach and unsupervised approach. Then our methodology begins with the data acquisition. The 11 type of fiber curves are obtained from the previous study, and this data consists of 15 subjects ranging in age from 5 to 17 days. And these data contain T1 MRI data and diffusion weight MRI data. Then these both data are pre-processed using FSL software in 4 levels. Initially, the artifact correction to correct the subject motion and geometrical distortion. Then the eddy current corrections to remove the artifact occurred by the gradient coils. Then the brain extraction to remove the non-brain tissues. Finally, the output is registered in the MNI 152 space. Then the whole brain tractography performed on the diffusion weight MRI data. Then the region of interest preparation done on the T1 MRI data in order to cluster the cortical and subcortical region. And this is the overview of our training set construction. Initially, the T1 weighted MRI and diffusion weight MRI data are pre-processed. Then the brain parcellation performed on the T1 weighted MRI data and the whole brain tractography done in the diffusion weight MRI data. From both output, the training set curve bundles are manually extracted with the help of an expert. And in the figure, you can see these are the 10 major white matter bundles that we used in our work. You can see its shape and the location where it's reside in the human brain. In this table shows the number of curves we obtained for each of the major fiber bundles and the number of curves that we used for the training and testing purpose. In our method, the data sampling is an important part. Each curve we sample to a fixed number of coordinate points, that is 256 coordinate points. In the figure, you can see the top curve shows the original curve. Then the mid curve shows we found the mid value of each pair of original curves. Then the bottom curve, that our sample curve, we obtain the original points then we randomly selected the computed point for our sample curve. And this is the overview of our proposed network architecture. We named our architecture as TrackNet. Our TrackNet architecture takes the input fiber as a three-dimensional curves, and our architecture begins with the input transform network, that is TNet, and it followed by a multi-layer perception network, and it consists of two channel attention modules. Finally, each input curve is segmented to the one of the 11 classes. The beauty of our architecture is it is not only applicable for the fiber curves, as well it is applicable for any three-dimensional curve segmentation problem. And in our architecture, we have three main components. Initially, the input transform network. The objective of the TNet is to produce the permutation invariant global feature vectors. That is, it is a canonical form of input. Then the multi-layer perception network to study the segmentation knowledge. Then finally, the channel attention module to boost up the segmentation performance. And this is the detailed view of our TNet. Each input curve is fed into three convolutional layers, and it followed by a global average pooling layer. Then the output feature and the input feature perform to be the matrix-wise dot product, and the output is fed into the multi-layer perception network. And this is our channel attention modules. The feature is fed into the global average pooling layer, and it followed by two fully connected layers in order to produce the channel dependencies using the sigmoid activation function. Then the channel dependencies and the features are element-wise multiplied. This channel attention module is included in our architecture in order to boost up our segmentation performance. In our training, we upsample each bundle curves to a fixed amount. Then we divide the 80% of curve for the training and 20% of curve for the testing. Then we use sparse categorical cross entropy loss function. Then we tune the values of learning rate, batch size, and dropout parameter based on our validation result. This is our implementation details. We implement using the Python language with Google Colab Cloud Platform using Keras library. And this is the evaluation criteria in order to find the accuracy and precision and the recall. And this is the table shows our accuracy received by our architecture. And we compared our average accuracy with the related work results. This shows our architecture shows the better performance than the related work. And this table shows the precision and the recall values of each major fiber bundles individually. In this table, when we are using the channel attention module, we obtain 97.06% accuracy. But without the channel attention modules, we only receive 96.35% accuracy. This shows our channel attention module boosts up the segmentation performance. And in this figure, you can see for a sample test subject, we obtain the segmented bundle and for the training set bundle. The first figure of the bundle shows the training set bundle, and the second one shows the segmented bundle using our architecture. In the red color curve shows the missed curve from the training set bundle. You can see the output for all 10 major fiber bundles. So our conclusion, to our best of our knowledge, this is the first attempt to segment the white matter major fiber curves with their raw data format using CNN. Each curve fed into the CNN architecture to learn segmentation knowledge. And our architecture includes 2 channel attention module in order to boost up the segmentation performance. Finally, our proposed approach shows 97.06 average accuracy and was able to segment the curves within 2 seconds. And our future work is to evaluate the obtained outcome experimentally with more training set and to segment more major white matter bundle as well. And these are some references that we referred throughout our research work. Thank you for your attention.
Okay, thank you very much for your presentation and showing us your outcomes. Now forum is open for the questions. Yeah, you can ask some question to motivate the researchers and get some clarifications. Okay, few questions to clarify. Then normally, have you consult any medical doctor regarding your outcomes? No, they normally expert in that area to get some idea about these results by referring the MRIs.
No, sir, we didn't consult with any medical people. That what we obtained the data set from the previous work of our co-author. So we use the same data set for our work.
Yeah, have you taken ethical clearance for this research work?
No, sir.
Right. Then how we are going to now accuracy point of view? Actually, if you can normally get some expert opinion, even it's a good as a suggestion. Then when you are saying accuracy, is there any benchmark model for you to compare?
No, because of the unavailability of the benchmark data set, we couldn't compare the results. So this is, but we compare our results with the related work, but they use different data sets and the input data set also different. So this is we use the data as a 3-dimensional curves.
Right.
So
yeah, okay, keep going. Okay, that's fine. Is there any question to ask? Yeah.
So my question is, how you get your data set from your co-author? How he managed to get this data set?
Sorry, sir?
No, my question is how you managed to get the data set for your research?
Yes, sir. The co-author, one of my co-authors did his work using these data sets. So we took that data set.
How he managed to get this data set? From where he got this data set?
He did his work in Singapore, sir. So he obtained using that Tractography and that hospital. He obtained the data set from the hospital.
What is the size?
Sorry, sir.
What is the size of the data set?
Data sets, we normally obtain the number of curves. No, so it the table shows that it contain more than 4,000 for the totally each bundle contain 4,000 curves for the each bundle, sir.
Hi, Chavindra Anasika. Just to add to what Aruna asked, in terms of when you say curves, in what format is that data? How is it represented, that 3D curves in your data set?
Each curve, sir, we perform, it's a XYZ points.
Right.
Each curve have a XYZ points. So it's a 3-dimensional.
Okay, right. Okay.
After performing the tractography, sir, we use that they use that fact algorithm for segmenting the curves from the diffusion weight MRI image. So as the result, it is a 3-dimensional points of each curve have a 3-dimensional points.
So when you say curve, if you get a single fiber, it has several curves going through the MRI when you get it, is it? So it's a series of X, Y, X, Z coordinates, is it?
Yeah, sir. Yeah.
Okay, right. Okay. I'm interested how you model that in the pre-processing and got that data into it. And right. Okay.
Thank you, sir.
Okay, thank you very much for the presenter as well as those who asked the questions. Then I would like to move to the next presentation. The paper titled The Comprehensive Analysis of Clustering Techniques with Feature Selection of Breast Cancer Recurrence Prediction by Rangika L. Silva and Harshani S. Pereira from University of Srijawardhanapura. Okay, session is over to you.
Hello everyone, I am here to present my research paper under the topic of a comparative analysis of clustering techniques with feature selection for predicting breast cancer recurrence. This research was conducted by me, KLH Pereira, under the guidance of Mrs. MD.R.L. Silva. First of all, let's see what is cancer. Cancer is a generic term for a large group of diseases that can occur in any part of the body. It is a leading cause of death globally, accounting for nearly 10 million deaths in 2020. Cancer arises from the transformation of normal cells into tumor cells in a period of time which are abnormal, uncontrollable, continuously replicating and inevitably lead to the formation of a tumor which often has the ability to spread throughout the body. Most common types of cancers in 2020 were breast cancer, lung cancer, and colon and rectum cancer. Breast cancer is a type of cancer where breast cancer cells usually form a tumor that can often be seen on an X-ray or sensed as a lump. Breast cancer is the most common cancer among women worldwide, and 1 in 10 women will develop breast cancer during their lifetime. Even men can get breast cancer too. Surgery is the most common first treatment for early-stage breast cancer, possibly followed by chemotherapy, radiation therapy, and then hormonal therapy. With early detection, this cancer has a 90% survival rate from treatments. However, chances are there for recurrence of the cancer. Recurrent breast cancer is the breast cancer that comes back after initial treatment. Even if the initial treatment is aimed at destroying all cancer cells, a few may have evaded treatments and survived. These undetected cancer cells multiply, becoming recurrent breast cancer, and cancer can grow back in the breast, the lymph nodes, or in the other parts of the body months or years after the initial treatment. Some of the risk factors for recurrence are lymph node involvement, large tumor size, young age, and obesity. The recurrent cancer cells are more resistant, aggressive cells, and require more aggressive surgery and usually chemotherapy when they recur. Hence, recurrent breast cancer is often considered more threatening than the original breast cancer situations years before. Signs and symptoms of recurrent breast cancer can vary depending on where the cancer comes back. There are 3 types of recurrence, namely local, regional, and distant recurrence. Sometimes a breast cancer recurrence can be found during a mammogram test or scan before it causes any symptoms. Conventional method to detect breast cancer recurrence is to check for any symptoms or sign of recurrence during the follow-up exams by oncologists after the initial treatments are done. Therefore, to overcome the delayed detection and absence of prediction, recurrence prediction is important because it will increase the survival rate, reduce the chance of undergoing aggressive surgeries or treatments, and reduce the side effect causes from cancer-fighting drugs. Therefore, recurrence prediction is the vital demand of every cancer patient. Therefore, considering the importance of breast cancer recurrence prediction, the solution was identified as a mathematical, computational, and statistical model to predict breast cancer recurrence. Therefore, our objectives were to develop models using clustering techniques with and without feature selection using a standard dataset, and to evaluate the most efficient clustering method to improve the accuracy of predicting breast cancer recurrence. Let's move to previous works done on breast cancer recurrence prediction. Mainly there were 6 areas: classification, clustering and classification comparison, classification with feature selection, neural networks, and ensemble learning. Research that was done using classification has used decision tree support vector machine algorithms, and clustering methods like k-means algorithm, hierarchical clustering, and cluster networks was used. And for the classification with feature selection, one research has used the particle swarm optimization with Navy Bayes and K-nearest neighbor, and other has used rank algorithm for the feature selection, and classification algorithms support vector machine, Navy Bayes, and decision tree. Thereby, most of the researches were carried out without using a feature selection method, and the researchers that carried out using feature selection has showed that their result showed improved accuracy rates with feature selection. Thereby, we have identified breast cancer recurrence prediction based on feature selection and clustering techniques as a research gap here. In our study, we performed breast cancer recurrence prediction based on feature selection and clustering techniques, and a comparative analysis of clustering techniques with feature selection and without feature selection. We have selected information gain feature selection algorithm as the feature selection, and 4 popular clustering algorithms: k-means algorithm, hierarchical k-means clustering algorithm, expectation maximization algorithm, and complete linkage clustering algorithm to conduct our research. Let's move to the design of our study. As the first step, data acquisition and preprocessing were performed. Data provided by the UCI machine learning repository, which acquired from the Wisconsin Prognostic Breast Cancer Subdirectory, were data taken from consecutive patients seen by Dr. Wahlberg since 1984, was used here, where it consists of 198 instances, and a single record consists of 34 attributes, and a class distribution of 151 non-recurrent instances and 47 recurrent instances. After that, data cleaning and pre-processing was performed, where unnecessary columns were removed and missing and null values were checked and replaced them with the mean value, and categorical data was converted to binary. Only categorical data present was target variable, and after that, scaling and normalization of data was performed. After performing data cleaning and preprocessing, model building was performed. Information gain algorithm was performed on dataset, where dataset was considered as a continuous discrete dataset, and nearest neighbor method was used to calculate mutual information of information gain. 5 features were selected out of 34 features, which identified as contributing most to the prediction variable, recur or non-recur. This graph shows the results obtained by conducting information gain algorithm on the dataset. After that, clustering evaluation without feature selection phase and clustering evaluation with feature selection phase conducted separately, where all 34 attributes were considered for clustering without feature selection phase, and for the feature selection phase, only mean compactness, recurrence or disease-free time, lymph node status, worst smoothness, worst texture attributes were considered. Finally, comparative analysis was performed. 4 models from with feature selection phase and 4 models from without feature selection phase were compared, and the most accurate and efficient predictive model is determined out of the 8 models created. Experimental results were shown in 3 phases: clustering evaluation with feature selection phase, clustering evaluation without feature selection phase, and comparative analysis phase. In clustering evaluation without feature selection phase, according to the results shown in the graph, it is very clear that the complete linkage and the expectation maximization algorithms showed higher scores for the evaluation metrics mostly. And in the clustering evaluation with feature selection phase, it is clear that expectation maximization algorithm showed higher evaluation scores for all 4 metrics, thereby expectation maximization algorithm outperformed other algorithms when feature selection was carried out before introducing the clustering. In the comparative analysis phase, the table shows that overall analysis of the clustering with information gain and without information gain feature selection. Result shows that expectation maximization algorithm with information gain feature selection outperformed the other algorithms, where it shows a recall score of 89%, precision of 33%, rand score of 55%, and Folke-Mello score of 55%. In this phase, evaluation of 4 performance metrics, recall score, precision score, rand score, and Folke-Mello score were also performed. We propose that we can improve most of clustering algorithms by using feature selection techniques, and we presented the results of our experiments on 4 popular clustering algorithms with and without feature selection algorithm information gain. Expectation maximization algorithm produced better output with and without information gain, whereas other techniques improved when used with information gain algorithm. After completing this study, we identified some future works in here: testing new neighbor clustering algorithms with information gain algorithm and other feature selection algorithms, and testing with different and bigger datasets of breast cancer recurrence. These are some references we referred while conducting this research, and thank you for your time.
Okay, thank you very much for presenting. Any questions from the audience?
Hi, it's Chavinder Ranasinghe. In terms of, I'm not clear about the features. You talked about dimension reduction, and in terms of feature, in the feature extraction, you talk about 12 prominent properties and original properties. What can you give us some examples of the properties that you have selected?
Just give a second. Actually, the data set is taken from the machine learning repository, and they had 34 features that they have calculated. The perimeter area and like smooth fractal dimension, like stuff of the nucleus, cell nucleus. Those are the 10 real valued features.
So these are the features from a scan, is it? From a
yes.
That you extract from malignant or non-malignant. Yeah, okay.
They took them from some digitalized images and then calculated the values.
Okay, right. And your data set is how many?
198.
And the test and the positive and the negatives, what's the percentage?
47 was recurrent, 151, as I remember, was non-recurrent.
So you have a problem of imbalance data set. How you balance the class balance?
Actually, I didn't much consider about that.
Another thing is for feature selection also you use the same data set, and for training and validation also use the same data set. So there's chance of
actually the clustering. So there was no training was performed. Hello.
You're doing information gain. So how you did this one?
Yes, for the information gain, yes.
You consider the class. Yeah.
Yes.
How to discriminate, no?
Yeah.
Okay, thank you very much. Only one concern for me. Have you consult any doctor or expert, a medical expert regarding this matter?
No, since the data set is a standard one, we didn't consult the medical expert.
But it's a medical kind of, because you are dealing with the human being, better to consult them as well. Otherwise, we can't give them a solution. Right? Okay, thank you very much for presenting, as well as the audience who have asked questions. Okay, thanking the presenter, I would like to move to the poster session. Actually, we have two posters to present. First one is EasyGo, Public Transportation Management and E-Ticketing System. Now, session is open for you all to share your poster and present it to the audience.
We introduced public transportation system and e-ticketing system, name called EasyGo. Our paper ID is 133. We have 4 authors in our project. Firstly, S.A. Ashan, Sri Lanka Institute of Information Technology, Faculty of Computing. Next, Dilshan I.H., Sri Lanka Institute of Information Technology, Faculty of Computing. Next, Bandar GRNN, Sri Lanka Institute of Information Technology, Faculty of Computing. Next, Karunasena PSA, Sri Lanka Institute of Information Technology, Faculty of Computing. EasyGo is a decentralized, intelligent and secure public transportation platform. Public bus transportation is frequently difficult to use due to a lack of real-time information on bus location and delays, which combined with operational delays and all necessary alerts in controlling system, make it difficult for users to estimate when buses will arrive and plan bus routings. The system considers a decentralized controlling system and dynamic bus schedule system-based machine learning approach, and QR code-based ticketing system and prediction system. Next, Modi problem statement. Lack of decentralized management and monitoring system to manage transportation. Current system having to store all transportation data in books due to lack of proper database for storing data. Due to the current static bus schedule, the number of overcrowded bus and low bus service has increased significantly. There are no way to find out how many buses will be used per day in upcoming days. Lack of real-time information on bus locations and delays bus fares collecting difficulty. Quick monitoring vehicles and notifying riders with estimate arrival times is necessary for a variety of reasons, including road congestion, operational delays, ride periods need to load passengers at each stop, and buses that are not comfortable due to overcrowding on most buses. Next, move to solution statement of our project. Overall, this study aims for secure and decentralized web application and mobile application for driver, passenger, and conductor. It facilitates an innovative and a better transportation process in Sri Lanka transport sector. Next, move to our objectives. Our main objective is to build decentralized, intelligent, and secure public bus transportation platform. Our sub-objective is to implement dynamic bus schedule system, user-friendly decentralized controlling and monitoring system, QR code-based cashless payment system, to implement separate app for passenger, driver and conductor and user-friendly web controlling system, revenue prediction system, and provide secure database connection system between web application. Next, move to system diagram. This was very important in developing the system. Here you can see a complete view of our overall system. Next, move to methodology. Develop attractive and interactive user interface, especially for the admin dashboard. Develop dynamic bus scheduling system using machine learning. Develop decentralized monitoring system and decentralized database. We are using 3 algorithms named as linear regression algorithm, logistic regression algorithm, and k-nearest neighbor algorithm. Next, move to algorithm accuracy for dynamic bus schedule system. When build a dynamic bus schedule system, we check the accuracy of 3 machine learning algorithms. They are k-nearest neighbor algorithm, linear regression algorithm, and logistic regression algorithm. Next, move to accuracy of dynamic bus schedule system. Then we selected the most accurate model and include it in our system. Most accurate algorithm is linear regression algorithm. Accordingly, we were able to build a successful full model. Next, move to revenue prediction model using linear regression algorithm. We also developed a model using linear regression algorithm to predict drivers' monthly income, and we were able to do that with good accuracy. Next, move to revenue prediction system model accuracy. Next, move to our dynamic bus schedule system interface. Then we were able to successfully integrate the dynamic bus schedule model to a web application and web interface. We believe that can be used in practically due to its user friendliness. Next, move to decentralized system admin dashboard. In here we can see a decentralized admin dashboard that can be easily used by transport officer to view and enter any information of passenger, driver and conductor. In here, the 3 mobile application we have introduced, and they are available in 3 variant, namely driver, passenger and conductor. They are all controlled by a single system and all are integrated. Thank you.
Thank you very much for the presenting your post. Now, forum is open for you all to ask any clarifications or any questions based on their title. Easy go. Okay, one question from me. How easy for us to use this pandemic situation, this kind of application?
Yes, it is easy to pay in bus fares and system.
Now, due to this pandemic situation, without touching the currency notes and coins, how we can use this system?
Yes, sir. We implement QR code payment system. In here, a passenger can passenger don't use in currency and fiat currency and those.
Yeah, how you normally validate this system? Is that working in accurate manner?
Sorry, sir.
Now, how you normally charge your A to B using your system? Then, what kind of accuracy you may have in your system?
Yes, we selected three algorithms: k-nearest neighbor algorithm, and linear regression algorithm, and logistic regression algorithm, and we.
Yeah, actually, how they work in accurate manner now. Think about if I try to normally get into bus in Nugegoda and get down from Colombo, then how accuracy the bus fare count compare with the manual system?
We already implement bus fares.
Yeah, then accuracy of the charge. Now think about if it's 100 rupees, your one also 100, or is that 95 or 110? In that way, what kind of accuracy with the charging amount?
96% accuracy we have.
Okay, but you need to do further improvement. You know, the passengers are a bit tricky, right? Then if you are not giving the 50 cents even, okay, they are trying to fight with the conductor. Therefore, you have to think about those things with your systems, right? Okay, any questions from the audience? Okay, thank you for presenting it. Then we will move to our second poster. It is open versus REST approach for the test scenario generation based on requirement specification. Yeah, session is open for you.
Hi everyone. This research is based on the one versus REST approach for test scenario generation based on requirement specification, which would facilitate the software testing domain. A requirement specification document is a highly rich source of information pertaining to a project. Extracting insights from the document can be a tedious task, as there is no definite mapping of system requirements to specific test cases, using the mixture of text and images in the document. As such, by capturing the requirements specified in text will facilitate an automation process of capturing accurate and effective models to generate the most recommended test scenario for the given input using machine learning and natural language processing concepts that could be applicable in industrial context. As per the past research, it can be observed that 68% of projects with efficient communication and well-defined requirements meet quality standards, while 32% of IT projects fail because of its unclear requirements at the planning stage. And it could also be stated that unclear requirements are responsible for 41% of the global IT development services. So according to past researchers, around 70% of researchers have been based on generating test cases with the use of UML diagrams and not text-based. So this research here focuses around classifying requirements and predicting the output for requirements entered by the user. That is, we focus on the usability, reliability, privacy, and the performance of how such a system could cope up with. The multi-label classification was used as a problem transformation architecture. That is, we use a one versus rest ensemble wrapper to break down a multi-labeling into a series of binary problems so that it could be tackled using binary classification. Due to the unavailability of the dataset for requirements, the dataset was manually created. The system was thus designed to take the user's input as a form of text, after which the text will go through a data cleaning process, after which the data pass will transform into a meaningful representation of numbers, which will be used to fit a machine learning algorithm to predict the output. The system was tested for both logistic regression and linear SVC models. And using the hyperparameter tuning, the one versus rest classifier with logistic regression model proved to perform better. The system was designed for web-based requirements as such. The main limitation to this research was the unavailability of the requirements dataset. So therefore, the system was then designed to predict test scenarios for web-based requirements. However, we hope to improve this model and assist all types of system requirements as a future enhancement. Thank you.
Okay, thank you very much. Now, any questions from the audience? Yeah, can you further elaborate us how you are doing your prediction here?
Yeah, so basically, there are SRS documents at any project initial stage. So basically, the system which I designed takes those requirements. The user has to copy paste those texts in the document and input it to this. It's a web-based application. So you copy the requirements and you enter it to this web-based application. So for those particular requirements, our system will predict the most suitable test scenarios.
Okay, then now can you elaborate further about your accuracy as well?
Yeah, so basically this is a multi-class classification. So I have used actually 6 methods of calculating the accuracy, because in a multi-class classification you can't only base it on the accuracy due to class imbalance and the data imbalance, because I created the data set. So actually I have focused on the Jaccard score and the Hamming loss mainly to select the model. So those two were the main parameters used.
Okay, any question from the audience? Okay, thank you very much presenting here. Okay, I would like to thank all the presenters and the authors who presented today, and the audience as well. I would like to conclude the session by saying one words, the remarks given by the researcher. He says research is seeing what everybody else has seen and think what nobody else has thought. With that great thoughts, I would like to conclude this session, handing the session to the Pumini. Over to you, Pumini.
Okay, thank you, Dr. Anuradha, for being with us today and sharing this session on machine learning. Now, I would kindly invite you all to join back to the main session for the next keynote speech. Thank you all for participating, and a great session. Thank you again, sir.
Thank you. Thank you.